Fossilized poop reveals secrets of how dinosaurs came to dominate Earth. The earliest dinosaurs were unremarkable, bit players on a supercontinent crowded with other ancient reptiles when they first evolved around 230 million years ago. Fast forward 30 million years, however, and dinosaurs dominated the planet, coming in all shapes, sizes, and forms, while many of their reptilian counterparts had died off. Exactly why they were so evolutionarily successful is a long-standing mystery. But new research suggests some answers to this question may be contained in what they left behind: dinosaur droppings. We know a lot about their lives and extinction, but not how they came about, said Martin Kvarnström, lead author of a study on the rise of dinosaurs published Wednesday in the journal Nature and a paleontologist at Uppsala University in Sweden. To better understand the extinct giants, Kvarnström and his colleagues investigated overlooked fossils known as bromelites, remnants from the digestive system, aka dinosaur poop and vomit. They studied more than 500 fossils gathered over a 25-year period from around 10 sites in the Polish Basin, an area in the south of Poland. The remains dated back to a range of time spanning the late Triassic to early Jurassic period, from around 247 million years ago to 200 million years ago. Bromelites contain so much paleoecological information, but I don't think paleontologists really have acknowledged that and have seen them mostly as like a joke. You collect a few coprolites because it's funny, Kvarnström said, referring to fossilized feces. They found that the fossilized poop and vomit, scientifically known as coprolites and regurgitolites, respectively, increased in size and variety over time, indicating the emergence of larger animals and different diets. By studying the shape and contents of the bromelites and linking them to fossilized skeletons and footprints found at the sites, researchers were able to identify and categorize the animals that likely produced them. Doing so allowed the researchers to understand how many and what type and size of dinosaurs, as well as other vertebrate animals, were in the landscape at a given point in time. The analysis, which took 10 years to complete, allowed the team to piece together why dinosaurs came to prominence. Revelations from ancient poop. In some cases, it was possible to make a visual assessment of what type of dinosaur was responsible for a bromelite based on a fossil's size and shape. A spiral-shaped coprolite likely came from an animal with a spiral gut, but in many others, it was necessary to take a detailed 3D scan of the bromelite's internal structure using specialized equipment to understand what the fossils contained. Ancient digestive remnants can look like something left by your dog in the park, and it's very evident what they are. In other cases, especially herbivores, they're more difficult to recognize, he said. The team scanned the fossil's internal structure at the European Synchrotron Radiation Facility in Grenoble, France. The massive facility, a ring-shaped synchrotron 844 meters, 2,800 feet, in circumference, generates X-ray beams 10 trillion times brighter than medical X-rays and allows scientists to study matter at the molecular and atomic level. It's a bit like a CT scanner at the hospital. It works in the same way, but with much higher energy. We need that to get this really high resolution and also good contrast, Kvarnström said. The coprolites contain the remains of fish, insects and plants, and sometimes other prey animals. Some remains were beautifully preserved, including tiny beetles and half-complete fish. Other coprolites contain bones crushed by predators. The skeletal fossils, footprints, and bromelites from sites in Poland provide a series of discrete temporal snapshots that demonstrate a transition from a world with few dinosaurs to one in which they dominated, said Lawrence H. Tanner, a paleontologist at the Department of Biological and Environmental Sciences at Lemoyne College in New York. Tanner was not involved in the study. Using the techniques from this study in other locations would provide a more global context and build a nuanced picture, Tanner wrote in a commentary piece that published alongside the research. Reconstructing dinosaurs' rise. The authors came up with 5 phases to explain dinosaurs' ascendancy. Their ancestors were omnivorous, eating plants and animals. They evolved into the first carnivorous and plant-eating, or herbivorous, dinosaurs. A key turning point came when increased volcanic activity may have led to a more diverse range of plants to feed upon, followed by the emergence of large and more diverse herbivore dinosaurs. In turn, This phase led to the evolution of the giant carnivorous dinosaurs beloved by movie directors and childhood books at the beginning of the Jurassic period 200 million years ago. The supremacy of the dinosaurs endured until an asteroid that struck off the coast of what's now Mexico 66 million years ago doomed the dinosaurs to extinction. Before this latest research, two theories had been proposed to explain the transition from a world dominated by non-dinosaurian reptiles to one in which the dinosaurs were ascendant, the study noted. One model suggested that dinosaurs evolved to physically outcompete their rivals, according to the study. The dinosaurs' upright stance resulting from the positioning of their hind limbs directly beneath their body, combined with flexible ankles, made them highly agile and more efficient than their evolutionary competitors, such as reptiles with splayed legs. Alternatively, some researchers believe dinosaurs were by chance better able to adapt to dramatic changes in climate that took place at the end of the Triassic. Kvarnström said the research based on the Polish fossils suggested a combination of the two hypotheses provided a more likely explanation, with a complex interplay of several processes that meant dinosaurs were better able to cope with how environmental shifts changed what food was available. For example, the study found that food residues extracted from bromelites belonging to Dicynodonts, an ancient mammal relative with a turtle-shaped head, suggested that creature had a restricted diet, feeding principally on conifers. It disappeared from the fossil record around 200 million years ago. Dinosaurs, on the other hand, appear to eat a wide array of plants. For example, the team found that the contents of coprolites from the first large herbivorous dinosaurs, the sauropodomorphs, contained large quantities of tree ferns but also many other types of plants and charcoal. The team suspects that charcoal helped detoxify the ferns, which can be toxic. Jegors Niedzwiecki, the study's senior author and a paleontologist based at Uppsala's Department of Organismal Biology, Evolution and Development, said the reason behind the dinosaurs' evolutionary success was a message that still applied today. Eat your veggies and live longer.